Hi, in this video we're going to take a look at solving systems of equations using elementary row operations. In our previous video we saw how the system of equations, the matrix multiplication, transforms the coordinate plane we started with into a new coordinate plane with a new x and y axis essentially. However, for many systems, especially those that have decimal or fractions for values of x and y, it may not be easy to determine those fraction or decimal values using the transformation of the coordinate plane technique. So, fortunately, we have what are known as elementary row operations to reduce our systems of equations to this form where our matrix that we're multiplying our variables by is the identity matrix, where we have ones along this diagonal and then zeros elsewhere. And then once we reduce it to this, we have the x coordinate of the answer on the top of the left or the right hand side, and the y coordinate of the answer on the bottom of the right hand side. Or if we move it back to a system of equation, it looks like 1x plus 0y equals whatever the x coordinate of the answer is, and 0x plus 1y is going to be whatever the y coordinate of the answer is. And so our elementary row operations, in order to transform the system that we start with to something like this, where we ultimately want to end up, we have three of them. And our first one, and this is in no particular order, is we can interchange two rows. And the notation that you're going to see me use for that is switching row number 1 and row number 2 with this double arrowhead. So it doesn't matter, if we graph our first equation, then our second, or our second, then our first. So we can interchange two rows without any penalty. We can also multiply a row by a non-zero number. So if we take 3 times row number 1, we can store that as our new row number 1. So these arrows that are pointing to the right mean we're going to store this result as our new, in this case, row number 1. We can also add or subtract two rows together. So row 1 plus row 2, and we can store that as our new row number 2. And we can even do a combination of row operations. So we can multiply a row by a non-zero number, like 3 times row 1, and add it to row 2 to produce a new row number 2. So we can take combinations of operations as well. So these are our three. And we're going to look at our previous examples using the elementary row operation techniques. We'll take a look at the ones that give an actual answer, and then in the next video we'll take a look at the special solution ones and how to determine that they are special solution answers using elementary row operations. So let's go to example 2A. Solve each using elementary row operations. So if we were to take a look at our coefficients here, we can create a matrix. It's called an augmented matrix. 1, 2 for the first column, then 1, 1. And then what we can do for these equal signs is we can actually draw a vertical line that'll separate the left-hand side from the right-hand side. And there we go. All right, so our goal, it's a pretty straightforward process. We first want to start by getting this value in the upper left equal to 1. Well, the good news is it already equals 1, so we don't have a whole lot of work to do. If it didn't equal 1 and we couldn't switch it with another row, then we would just multiply every number in that first row by the reciprocal to get it equal to 1. But we don't have to worry about that here. Next, we want to get the value below this 1, this 2 down here. We want to get this value equal to 0. And what's nice about having this equal to 1 is if we take the opposite of this number, the opposite of 2 is negative 2. If we take negative 2 and multiply row number 1 by it, and then add it to row number 2, we can store that result as our new row number 2. So if we take negative 2 times 1 and then add it to 2, negative 2 times 1 is negative 2. Negative 2 plus 2 will give us a 0 here. So let's see what we get when we do that. So our first row, notice the row that's over here, row number 2, that's the row that's going to change. So our first row, the one with all the ones, isn't going to change at all. So we can just copy that first row. But this row over here is going to be a new row after we do this these operations. So negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. And negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. So notice we have a new row number 2. All right, so now that we got that first column set where we have a 1 in the upper left and then a 0 below it, now let's move on to this next column. And again, our goal is going to be to get this number. We want the ones along this main diagonal here. We want to get this number equal to 1. And to do that, we can just multiply or divide row number 2 by negative 1. So if we multiply row number 2 by negative 1, so take negative 1 times row number 2, we can store that as our new row number 2. So when we do that, again, row number 2 is the one that's going to change. Again, pardon my penmanship. So negative 1 times 0 is 0. Negative 1 times negative 1 is 1. And then 1 times negative 1 is negative 1. So we got this number equal to 1. Now, we need to get this value here equal to 0. And once we have this number here in the second row, second column equal to 1, we can look at the number above it and take the opposite of it. Kind of like we did with the 2, we took the opposite of it and made it negative 2. So if we take the opposite of this 1 here is negative 1. If we take negative 1 and multiply it by row number 2, we can then add it to row number 1 to get a new row number 1. So row number 1 is the row that's going to change, which means we can copy the numbers that are down here. And let's see what we get. Negative 1 times row 2. So negative 1 times 0 is 0. 0 plus 1 is 1. Notice this first column, once we set it with a 1 and a 0, it's going to stay that way for the remainder of the problem. And that should always happen. Negative 1 times 1 is negative 1. Negative 1 plus 1 is 0. And then negative 1 times negative 1 is 1. 1 plus 1 is 2. And so now we have 1s along this main diagonal and then 0s elsewhere to the left of this vertical line. Remember, the vertical line represented the equal signs. Well, here, now that we have this matrix on the left side of this vertical line in this form, this 2 represents the x-coordinate of our answer. And this negative 1 represents the y-coordinate of our answer. So our answer to this system is x is 2, y is negative 1, which is exactly what it was in the previous video when we used the graph and the transformation of the coordinate plane in I hat and j hat. All right, let's try example 2b. This is another one where we solved this one in the previous video. But for right now, let's just go ahead and write the augmented matrix. So we have 2 and negative 1. We have 3 and negative 4. And on the right side, we have 12 and negative 11. Right. Okay, so again, we're going to start by getting this first value in the upper left, first row, first column equal to 1. Now it is a 2, and we could divide everything in row 1 by 2 or multiply everything in row 1 by a half. However, we can also, notice we have a negative 1 down here, we can also switch these first 2 rows, and that'll at least hold off on getting any fractions involved. So again, while we could multiply everything in the first row by a half, we would have a fraction here. And if we don't want to work with fractions, or at least try to avoid them, instead what we can do is we can switch these first two rows. So let's try doing that just to see that one in action. So row number 1 and row number 2, we're going to switch them. So, okay, -1, -4, and -11, and 2, 3, and 12. Would have been just the same if we would have written this equation first in the system. All right, so now we want to get this value here equal to 1, so it's a -1. So if we just take -1 and multiply it by row number 1, we can get a new row number 1. So all we're going to do is we're going to change the signs of everything in row number 1 and get 1, 4, and 11. Again, notice row number 1 is the one that changes. So row number 2 we haven't done anything with yet. All right. Now that we have this equal to 1 in the first row, first column, we want to get the value below it equal to 0. So just like in the previous problem, since this is a 1, to get this is equal to be a 0, we just have to take the opposite of what this value is. So the opposite of 2 is -2. If we multiply row number 1 by -2 and add it to row number 2, we can make that our new row number 2. That's row number 2. So let's see what we get. Well, row number 2 is the one that's going to change. So let's just go ahead and copy row number 1, since nothing's going to change there. So -2 times 1 is -2. -2 plus 2 is 0. -2 times 4 is -8. -8 plus 3 is -5. -2 times 11 is -22. -22 plus 12 is -10. So there we go. All right, so we got this first column, 1 and then a 0 below it, and it should stay that way throughout the remainder of the problem. So now we have this -5. We want to get this equal to 1. So we want to get this -5 equal to 1. We can take row number 2 and multiply it by -1/5. You can also, if you want, I'll let you get away with row number 2 divided by -5. Which is the same as -1/5 times row number 2. That's going to be our new row number 2. So again, row number 2 is the one that's going to change. So let's see. Well, our first row is going to stay the same since row number 2 is the one that's changing. And 0 divided by -5 is 0. So again, that column is set. -5 divided by -5 is 1, and -10 divided by -5 is 2. All right, almost done with this problem. We have this as a 1, so we have 1s along the main diagonal. We want to get this equal to 0, so we can take the opposite of 4, which is -4. If we multiply -4 times row number 2, we can then add it to row number 1, and that should be our new row number 1. Glad I gave myself enough space. So row number 1 is the one that's going to change. So we'll keep the 0, the 1, and the 2. And let's see, -4 times 0 is 0. 0 plus 1 is 1. Again, that column is set. 1 times -4 is -4. -4 plus 4 is 0. And then -4 times 2 is -8. -8 plus 11 is 3. So now we have to the left of this vertical bar, we have 1s on that diagonal and then 0s elsewhere. This 3 is our value of x. And this 2 is our value of y. By the way, this augmented matrix is written in what's known as reduced row echelon. There's a new word. Echelon form. Reduced row echelon form, often abbreviated RREF. So our solution to this system, which again we saw in the previous video, is the 0.32. All right, in the next video we'll take a look at special solutions using elementary row operations, but that about does it for this video. Thanks for watching. I'll see you in the next